Hello, everyone, and welcome. Today, we're going to dive into one of the biggest questions out there, one that sits right at the intersection of philosophy and cosmology. We're going to explore this idea called fine-tuning and look at the argument that the almost unbelievable precision of our universe might just point towards a guiding intelligence, a sort of cosmic mind.
So let's start with a thought experiment. Picture this. It's the year 2070. You're an astronaut, the first human to ever set foot on a planet way out in some distant solar system. You step out of your ship, and what do you see? Rocks, dust, a completely barren and lifeless world.
But then, as you're exploring this desolate landscape, you come across something that just seems impossible. It's a huge, self-contained greenhouse. And inside, it's a perfect little paradise. The oxygen levels, the humidity, the nutrients in the soil, everything is engineered perfectly for complex life to thrive.
Now imagine an alien ambassador shows up and you ask, wow, who built this incredible thing? And they just shrug and say, oh, nobody built it. It just happened by pure chance. Would you buy that explanation? Of course not. Your gut, your reason, everything would tell you this was designed. So here's the question. If we wouldn't accept that for a small greenhouse, why would we accept it for the entire universe?
That's the core question we're going to unpack today. Here's our roadmap. We'll start by defining what this fine-tuning principle really is. Then we'll dig into the evidence, both from the huge universal constants and from our own little solar system. After that, we'll weigh the two big explanations, chance versus design, and we'll finish up by talking about what philosophers call an inference to a mind.
So, let's get into this main idea. The fine-tuning argument basically says that our universe isn't just a random jumble of stuff. Instead, it seems to be balanced on an impossibly thin knife's edge.
And here's the formal definition. Fine-tuning is this observation that the fundamental numbers of physics, the constants that make reality work, have to be in this ridiculously narrow, life-permitting range. If you were to nudge any of those dials, even just a tiny, tiny bit, well, you and I simply wouldn't be here to talk about it.
So what are these constants we're talking about? You can think of them as the basic recipe for reality. They're the ingredients and the instructions in the universe's cookbook. Let's take a look at a few of the most important ones.
This is where things get really wild. Look at gravity. We all know it pulls things together. Make it just a little bit weaker, and stars and galaxies never form. You get a cold, empty universe. Make it a little stronger, and everything might have collapsed back on itself right after the Big Bang. Or how about the strong nuclear force? That's the glue that holds atoms together. Tweak that number slightly, and boom, the universe is either just hydrogen or one giant black hole. No complexity, no structure, no life. It's an unbelievably delicate balance.
So this forces us to ask a really profound question. How in the world did all these fundamental forces just happen to land on the exact razor-thin values that are perfect for us to exist? From a philosophical perspective, that kind of coincidence just begs for an explanation.
Okay, so we've looked at the big, universal picture. Now let's zoom in, way into our own cosmic neighborhood. Because it turns out this pattern of fine-tuning doesn't just apply to the laws of physics. We see it right here in our own solar system.
And first up, let's talk about Jupiter. That big, striped planet isn't just out there looking pretty. Its size and its exact location are absolutely critical for our survival. You can think of it as our cosmic bodyguard.
Seriously, Jupiter acts like a giant shield. Its immense gravity is like a cosmic vacuum cleaner, sucking in or flinging away countless comets and asteroids that would otherwise be on a collision course with Earth. Without Jupiter on duty, our planet would have been constantly bombarded, and it's very unlikely that complex life would have ever had a chance to develop.
Okay, now let's get even closer to home. Let's talk about the moon. It's so familiar we barely think about it, but our moon is much, much more than just a nice nightlight. Its existence is essential for having a stable climate here on Earth.
So, here's the deal. The moon's gravity acts like a stabilizer. It holds the Earth's tilt steady, and that's what gives us our relatively stable seasons and long-term climate. Without the moon, the Earth would wobble chaotically on its axis. We'd have wild, unpredictable swings in climate that would make it absolutely impossible for complex life to hang on.
So we have all this precision, from the fundamental forces of the cosmos all the way down to our own moon. What's the best way to explain it all? Well, it really boils down to two competing ideas.
On one side, you have the design hypothesis. This says that all these perfect conditions were set up on purpose. And on the other side, you have the chance hypothesis, which says that we just got unbelievably lucky, like we won a cosmic lottery with odds that are almost impossible to imagine. Now, to make the chance idea a bit more palatable, some will point to the multiverse theory, the idea that there are infinite universes. So it's no surprise that one of them, ours, just happened to get the recipe right.
But as critical thinkers, we have to ask ourselves, is chance really a satisfying explanation here? Think about it. If you saw a masterpiece painting and someone told you it was just the result of some spilled ink, you'd be rightly skeptical. We instinctively know that pure chance doesn't create things with high levels of complex, specified information. So why would we be so quick to accept it as the explanation for the universe itself?
Even some of the greatest scientific minds have felt this sense of awe. Einstein had a wonderful analogy. He said, "We're like a child in a massive library. The child can't read the books, but he sees them all meticulously arranged on the shelves, and he just knows someone had to write them and organize them."
And this isn't just a one-sided observation. Even a famous atheist thinker like Richard Dawkins has said that our planet is miraculously all but perfect for our kind of life. So the data itself isn't really in dispute. The big debate is over what explains that data.
So where does all this leave us? We've got the evidence and we've got the competing explanations. Now we have to weigh them and try to arrive at the most logical conclusion.
In science and philosophy, we have a tool for this. It's called inference to the best explanation. It's not about finding absolute mathematical proof. It's about looking at all the evidence and saying, which theory makes the most sense of all the facts we have?
And when we apply this tool to the evidence of fine-tuning, the argument concludes that the most logical, most coherent explanation isn't random chance. It's that a lawmaker, a grand designer, a cosmic mind, if you will, intentionally set up the laws of physics and the conditions of our universe to allow for life like us to eventually show up.
So I'll leave you with a final thought to take with you. The next time you're outside and you see the moon up in the sky, remember how critical it is for our stable world. And just ask yourself, is its perfect placement just a happy coincidence? Or could it be a clue pointing to something much, much bigger?
Something to think about. That's all for today. Class dismissed. I'll see you all at our next session.